Alright, next we're going to talk about using Java and other code in a Clojure program. So we have a couple of ways to access different libraries. We have require, refer, use, and import. So require is used to load a library, and when we require something we have to use a fully qualified name. So here's some code that is requiring Clojure has its own string library. So here's how we require that particular library. And then if we want to use any one of the functions in that library, there's one called join, which will create a new string with these whatever token we specify here in between. We can call that function, and here we'll print it out. You see the dashes in between the different strings here. Okay, refer allows us to create aliases to use names without being fully qualified. Okay, so we're still requiring the Clojure string library. Now we're referring it also. So now we can just call join, and this should work. Notice, however, we do get a couple warnings. So there are some functions in the string library, in particular one called replace and one called reverse, which are also part of the core Clojure library. And the fact that we're referring the Clojure string library means that we're now giving preference to this library rather than the core. And this warning is just giving us a little warning message about that. We have use. Use both requires and refers in one step. Okay, so we're using the Clojure string library, and we should still get the warning messages. Okay, and we can still call join. Lastly, we have import, and this is used to refer to built-in Java libraries. Libraries not written in Clojure, but the ones that come with the Java SDK in particular, or anything that's on your class path. Okay, so here's how we import. So we create a list, and we give the name of the package first, and then a list of classes within that package. So we want to be able to use random and locale from the util package. We don't actually do anything with them right now. We'll talk about how that works in a second. Okay, so in order to create Java objects, we're going to use this thing called the new function. Right, so there's actually a Clojure function called new, which, not surprisingly, allows us to create these Java objects. Okay, so we're importing the random class from Java util, and this is my preferred way of creating a new Java object. So there's a function called new, and we give the name of the class. So now rangen is a reference to the random number generator that I just created in this step. Okay, then down here, in order to call a method on this object, we'll see this kind of strange notation here. We have a dot, an object, a method call, and a parameter. And this should print out the next random number. Okay, so it's 4. We have 2. This last parameter, I think, says the upper bound of where the random numbers should come from. Okay, so any random number between 0 and 9, I believe. Okay, there's another notation to create an object, which I guess is a little shorter anyway. I don't think it's very much more readable. In fact, I think it's harder to read. But whenever you give the name of a class and a dot, that is the same as saying, give me a new random object. Okay, so you might see this in some Clojure code or some Clojure books. I prefer the very explicit new random to me, we only are really saving 2 keystrokes, between this, and this just doesn't seem as straightforward to me. So in my code, you'll almost always see me use the new style. Okay, it's quite common to create a namespace for your code. So different languages have different ways of creating a namespace. We can do this in C++, we can do this in Java. A namespace allows you to define things with a qualified name. Then if another programmer chooses an identical name for something, it can be identified by the namespace that it's in. Okay, so we use the ns function to do that. This says create a namespace called marks code. And when you create a namespace, you can also use some of the other things we talked about before, use, import, okay, and so on. So now I'm going to create that random number generator, and then I am going to get a number and then call the join function. Okay, now the names of these things now belong to my namespace. Okay, in order to use Java classes, Clojure provides the ability to call Java code directly without creating Lispy wrapping code. So using Java classes actually feels like Java, but with slightly different parentheses. So to call a method on an object, you can use one of 2 dot notations. And we've already seen one, so let's take a closer look. Okay, so the 2 styles for calling Java code, if you have an object, we can use this style. So this says give a dot and the method name first, followed by an object. In this case, the object is a string, and then any parameters to the method would come after this. But the Java's 2 uppercase method doesn't take any parameters, so it's just the name of the method, or I'm sorry, dot and the name of the method, and then the object. Okay. Now there's a different style, I guess, of doing the exact same thing. This says put a dot first, then put an object, then put the method name, and then have any parameters that you want to pass to that method. I kind of prefer this style just because it feels more like Java to me, where we have an object, we have a method, and then we have parameters. And the dot just tells you, well, we're calling a function here. So either one of these work just fine. I probably prefer this one here. Now, sometimes we're going to chain calls together. So here's an example where we're trying to get the system properties. So here I'm using the system class. I'm calling the get properties. Right, that returns an object. So here I'm going to call a method on that object. The method name is called get, and the parameter is the operating system name. So there's actually a shorthand for chaining calls like this together, where we call a method and get an object, and we want to call another method on that object right away. And the shorthand is just 2 dots. So this says get the system properties and call the get method with the operating system name. Okay, so we should see my name in uppercase twice and the operating system twice. To access static or class-wide data members or functions, we're going to use the name of the class instead of the name of an object. Okay, so this is how we would get the value of pi from the math class. So pi is a static data member. So we could either use this notation, dot, the name of the class, the name of the member, or there's a shortened syntax, which I actually kind of like this. This says go to the math class and pull out the pi member. And here we have 2 pi's. we can implement an interface or extend a class in Clojure using the proxy method. Okay, so there is a method called proxy, and then we give the name of the class or the interface that we want to extend or implement. We give any values that we want to pass to the superclass constructor, and then we can override whatever functions, methods of that class or interface that we'd like. So we give the name of a function, the parameter list, and the bodies. So let's pretend we had this interface called foo on our class path, and the foo interface has a method called bar. Okay, the way we would implement this interface in Clojure is we would define a reference, foo_impl, and then we'd call the proxy method, and we're saying we want to implement the foo interface. There's nothing to pass to the base class constructor, so we'll leave that empty. This says we want to provide an implementation for bar, which is the only method in that interface. Bar takes no parameters, and the implementation is going to be a call to print line, and we're going to print that string. Okay. Now we could use this reference, foo_impl, and we could call the foo method, and that should print out inside bar. Okay, let me grab a different example. This one we can actually run. Okay, so here I'm defining a reference called runnable_impl. I'm calling the proxy method, and I'm saying I want to implement the runnable interface, which is part of the standard Java core. There's nothing to pass into a base class constructor, so I leave that vector empty. And then I want to override run. Run, you might recall, takes no parameters, and all I'm going to do inside the run is just print out inside run. Okay, so to test this, I'm going to create a new thread. And when you create an object using new, if the constructor has some parameters, those come right after the name of the class here. So you might recall, to create a thread, you can pass in a runnable. Okay, so this will create a new thread object that we then call start on. And hopefully we'll see inside run. Okay, so that's just a brief video about how to use some things from Java and from other libraries.